All right, we need to talk about the unit circle. Here it is. This is everything you need to memorize on the unit circle, which I know seems like a lot of information, but I'm going to go through it and show you how you can make this really easy, where there's very little to remember, hopefully. So we have this unit circle. Now, there's two things that you want to know about this unit circle, and these triangles you learned about in geometry class. There's two special triangles, 30, 60, 90, and you also had an isosceles right triangle, which was a 45, 45, 90. And these make up all the values that are on your unit circle. So the relationships were the small side was x of 30, 60, 90. The longer leg was 2x. This was x squared of 3. And then in the 45, 45, 90, these are the same. It's isosceles. And the hypotenuse was the shorter leg times the square root of 2. Those are your values. So what you'll see is that if you place this here, you make this triangle. This is a 30-degree angle, and this is a 60-degree angle. So this side's x, this side's twice that, and this side's x squared of 3. So when you want this value right here, the x value, that's the cosine. So the cosine is adjacent over hypotenuse, which is x squared of 3 divided by 2x. And what you find is those x's cancel, and you get square root of 3 over 2. So where that comes from, the square root of 3 over 2, it comes from the cosine, which is the adjacent to hypotenuse side in all 30, 60, 90 triangles. I've used x here, so x can be anything. Turns out, in this case, the hypotenuse is 1, so x must be 1/2. In which case, that's another thing you can do is just fill out, this is 1/2, and this is 1/2. So then you get, the x and the y, which is the cosine and the sine for both of these. So they come right from your special right triangles here. Obviously, I can do the same thing with a 45, 45, 90 triangle right here, where this is x, this is x, this is x squared root of 2. And you'll see then that adjacent over hypotenuse is x divided by x squared root of 2, which the x's cancel, and you get 1 over the square root of 2, which if you rationalize the top and the bottom, that's just the square root of 2 over 2, which is exactly what we have here for the cosine, the x value. So, once you get this first quadrant done, which you can do, like I said, with special right triangles, the last one being this triangle here, which is also a 30, 60, 90, and you do the same thing, x, 2x, and x squared root of 3, and do adjacent over hypotenuse, you'll get 1/2, and so on. But if you do that, once you get your first quadrant done, then you just fill it out. So once this first quadrant's done, let me write it down here. Obviously, we're talking about 0 degrees, or if we go all the way back around, that'd be 360 degrees. And then the points here are cosine is obviously you go out 1 and up 0. The next point is the 30, 60, 90 triangle that we did, and we found out that you go over square root of 3 over 2, and you go up 1/2, and that's 30 degrees. Next is 45 degrees, where we found you go over square root of 2 over 2, up square root of 2 over 2, and then we did this one and got just the opposite. So this one you go over 1/2 and up square root of 3 over 2, and this is a 60-degree angle. Now, once you get these done, I'll hold off on the radians for now, but once you get these done, it's really easy to see what the other ones are. This is obviously 90 degrees. You go over 0, up 1. Now, this one you'll notice has the same y height. So you can use the same y coordinate, square root of 3 over 2. This one, once again, same y height as this 45 right here. So, it's got to have the same y coordinate, square root of 2 over 2. Same thing with this one here. It's got the same height as the 30, so obviously we're going to use the same y coordinate. Now the x coordinates are just the opposite, right? If we went over 1/2 to get to this point, obviously we're going to go back 1/2 to get to this point. So it's just negative 1/2. You just change the sign on the x values from the first quadrant right here. So this would be back square root of 2 over 2, and this would be back negative square root of 3 over 2. Now you just follow that same reasoning, to get to these down here. Obviously these have the same x coordinate. So, you just copy down the same x coordinates here. Obviously this is negative 1, 0, and we just copy down the same x coordinate, square root of 3 over 2, negative square root of 2 over 2, and negative 1/2. Now the y coordinates are exactly opposite. If I went up 1/2 to get to this point, I go down 1/2 to get to this point. So I'm looking at negative 1/2. Same thing here. If I went up square root of 2 over 2, I'm going to go down square root of 2 over 2 to get to this point down here. So it's negative square root of 2 over 2. And then same thing here. If I went up square root of 3 over 2, I go down square root of 3 over 2 here. So they were just reflected images of each other. You know, if you take this point, reflect this over the line, obviously the x-coordinate stays the same, and you get the opposite of the y-coordinate. So just finish that off. Now the only thing you have left is the radians. Now obviously this is 0 radians or 2 pi if you go all the way around the circle. So these ones are easy. This is 90 degrees or pi over 2. This is pi. This is 3 pi over 2. I actually forgot the degrees here, so really you should go and add 30 to this to get 120. Add 45 to 90 to get 135. You know, subtract 30 from 180 to get 150. Then you have 180. Add 30 to get 210. Add 45 to 180 to get 225. You know, maybe subtract 30 from 270 to get 240. This is 270. And add 30 to get 300. Add 45 to 270 to get 315. Maybe subtract 30 from 360 to get 330. And you're done, minus the radians. Now the radians are going to be, look at that in terms of angles. So what I like to do is I like to sort of sketch the increments of 30 here. 1, 2, 3, 4, 5, 6. There's 6 equal parts of 30. So you can look at that in terms of fractions. So obviously the first one is going to be pi over 6 because it's 1 pi of 6. The next one's going to be 2 pi of 6, which 2 pi of 6 reduces to pi over 3. I'm sorry. That goes right here, pi over 3. And just continue that on. This is going to be pi over 4, pi over 5, and 6 pi over 6. I'm sorry, this is 1, 2, 3, 4 pi over 6, which simplifies to 2 pi over 3. So this should be 2 pi over 3 right here. Now you can do the same thing with the 45s, you know, split this up into 1, 2, 3, 4 equal parts, right? And now you can say, okay, well, this one is just 1 pi over 4. This would be 2 pi over 4 or pi over 2. This would be 3 pi over 4. And this would be 4 pi over 4, which is just pi. So you can use fractions, you know, to get that. The other thing you can do, if you don't like that fraction method, you can do the same thing down here. You know, take pi and add pi over 6 because that's 30 degrees, right? So you can do pi plus pi over 6. Get a common denominator and add it. You get 7 pi over 6. So this angle right here is 7 pi over 6. So you can do all kinds of things. The other thing you can do is convert. So if you don't like that, take the 210 and convert that to radians by multiplying by pi over 180. And then obviously we can simplify this. 30 goes into this 6 times and 30 goes into this 7 times. So it ends up being 7 pi over 6 if you convert that way. However you want, you can fill these out. If you do that, you can finish it off. And just take your time, you know. What you'll find is that there's very little you have to remember. If you know your numbers, if you know your fractions, and you also know your 2 special right triangles here, you can really fill this whole thing out without memorizing much at all.